So the next theorem is called as the Gauss Divergence Theorem. All right, so this is a statement. Let us say, now we are going to consider a volume. Okay, so if V, capital V, is the volume bounded by a surface, capital S, and say there is a vector F is continuously differentiable vector function. Then triple integral over the volume V of, so we write the divergence, so we will denote as div, okay, divergence of the vector F dv is nothing but the double integral over the surface S of the vector F dot the ds vector, right? Once again, we'll use the ds vector using this notation. What is ds vector? We use this yesterday, correct? It's a surface ds into the unit vector n cap, which is perpendicular to the surface. Okay, so this is the statement. Normally, this is in applications, it's a divergence, right? Have you heard of the term which dot product? Sorry, I didn't get your question. Can you come back again? DIVF means divergence of the vector F, right? So I can rewrite that. So DIVF, I'll write here, right? So this is the divergence of the vector F is denoted by, have you come across this symbol, del dot? No, yesterday's was different. That's not divergence, that is a curve. Del cross. So that's what, right? What we did yesterday is not what we are going to do today. Yesterday's was called as a curl. Okay, that's a curl. This is a divergence. All right, so this is del dot F. Okay, right. Okay, first question based on this. If vector F is equal to 2 times x squared minus 3 times z into I cap minus 2xy times j cap minus 4x times k cap, find the triple integral over v, the del dot f vector dv where v is bounded by x equal to 0, y equal to 0, z equal to 0, and 2x plus 2y plus z equal to 4 planes. All right, so this is the question. Right, so we'll start with first finding the del dot f. Okay, so how do you calculate the divergence? This is del dot f is nothing, right? So the whatever is with I, you differentiate that with respect to x. Okay, because the del operator, for the first problem, I'll write what is the del operator. So this is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap. This is the del operator. Take a dot product with the given function. Okay, so that should be 2x squared minus 3z into I cap minus 2xy into j cap minus 4x k cap. Right, so now we take a dot product, which makes sense. Only I can be multiplied with I into I is 1. Okay, so only those terms I'm able to multiply, right? So this becomes dou by dou x of 2x squared minus 3z, because I'm able to multiply I into j and I into k are zeros, right? So next, plus the dou by dou y of minus 2xy plus the dou by dou z minus, 4x. Okay, now you tell me what is this. So 4x minus 2x plus 0. So this is, oh sorry, this is x, right? So just see the equation. This is, there is x. Okay, so that means I'll correct, this is x. Okay, yeah, so now, so this is 2x, I guess. Right, now I need to understand, right, from where to where I'm, see there are several planes, right? So the planes are something like, when I say x equal to 0, that is yz plane, correct? Because everything is a plane now, planes. So all given equations are not straight lines, they are planes. So, right, x equal to 0 is yz plane, y equal to 0 is zx plane, right? Z equal to 0 is a xy plane, right? They are the minimum values of all the variables. Like when I say x equal to 0, it's a minimum value of x. It will go all the way until this point, correct? Until a, right? Until the x coordinate that is present on this particular plane. So what we can do, right? You can try to find z from the given this thing. Then we'll come one by one down to calculate y and what is that? Y and x values respectively. Okay, so start from this. So they have given 2x plus 2y plus z equal to 4. You see, you need a triple integral now. You need three limits. This implies, what is the z value from this? That is 4 minus 2x minus 2y. So z is the upper limit of z is this, correct? Now, which means you completely are taking care of the z value starting from 0 till this. Okay, so now you see, once you finish this integral, z is gone. No more z, correct? No more z means I can find out, I can use the same equation with the z being equal to 0 to find out the limits of y, correct? Are you okay with that? So it says 2x plus 2y equal to 4. Now you tell me what's the value of y that you are going to find from this. This is the upper limit of y. So that is 2 will get cancelled. So 2 minus x, I guess, right? Now you see, in the second integral, I'm solving, right? The y limits. So y is completely gone, right? When y is not there, I can find the limit of x, correct? So that is 2x equal to 4. So that means upper limit of x is equal to 2. So I could find everything. I just have to substitute in the given question. So question says solve triple integral del dot f dot dv. Right. So this implies, right, the triple integral over volume, the del dot vector f dv is equal to, so I know that last limit will be x, that is 0 to 2. Okay, next one should be y, 0 to 2 minus x. All right, so the third integral is z, starting from 0 going all the way till 4 minus 2x minus 2y. Is it okay? And write your function, right? What's a function? That is 2x. Del dot f vector, we found that as 2x, isn't it? Now, depending upon how we do the integration, right, dz, then dy, dx. So problem is, now the problem became a simple triple integral problem. Okay, when we solve this, we get this is equal to 8 by 3. All right, one more question. So okay, this is the question. Again, this is actually taken from physics, where, okay, I'll explain. Let me write the question first. If vector f is equal to 2xy times I cap plus yz squared into j cap plus xz into k cap with s as the surface of parallelepiped bounded by x equal to y equal to z equal to 0 and x equal to 2, y equal to 1, z equal to 3, find the flux passing through S. Have you heard about electric field? Okay. Can you tell me what it is? Okay, you tell number of electric line passing through given area, right? Right. So, no, no, the answer is very close, right? So this is actually, right, the flux is, as you told, right, the lines which we are talking about are imaginary. They practically do not exist. But anyway, for our understanding, we say that from a positive charge to a negative charge, there is a, sorry, there will be many lines, right, connecting. In the sense, if you place a charge in between a plus and minus, right, the test charge will move in some direction, correct, along a path. So that path is what we are considering as a electric lines or fields, correct. Okay, perfect. So now, so in the sense, let me consider a case. This is a, there is a plus charge, there is a minus charge. Between them, you have, right, many electric field of electric lines of fields possible. Okay, let's imagine. So this is what we are considering right now. Now you see, they are saying that there is a parallelepiped, right, which could be something like this. I'll assume. This is, okay, I'll make it shorter. This is something like this. Let's consider. All right. So this is what they have, right? They have given the various surfaces over here. Now the question is, right, out of the flux that is generated between the two, or so you see that there is the total strength, right? The total strength of the force of attraction or repulsion between this plus minus is nothing but the F, that is a field, electric field. Okay, out of the field, right, some part will pass through this, right, the parallelepiped, right. So that is the flux which they are asking about. How much is the flux? Fine. So right, so now the this is actually a practical question, right? Maybe in some subjects you will study later if the subject is there for you in your syllabus. Okay, but the idea is that if you want to calculate this flux in any given surface S, right, that means you are supposed to do a very simple calculation, right, that is derived directly from the Gauss divergence theorem, right? So we want to calculate the flux phi is equal to, it's a simple double integral over the given surface, right? Perform the F vector dot the ds vector. This is a question. Okay, this is what I'm supposed to do. But how this is related to Gauss, I know that because f dot ds is nothing but this is what? This is triple integral. I don't have to do the surface integral. I can easily do the triple integral rather than doing that. Okay. So this is triple integral, right? So del dot f d. Okay, so that's why this question comes under the Gauss divergence. Actually, I am supposed to find this, but I apply Gauss divergence to get this, right? And I will solve this particular question. Now you see everything is given. So I need to find out what is del dot f first. So f is given, right? F is equal to this 2xy. Let me check the question once again. 2xy I cap, yz squared j cap, xz into k cap. Yes. Okay, so let's start. So my first objective is to perform the del dot f vector. Okay, so that means I should do dou by dou x of the first term, that is 2xy, correct? Plus the dou by dou y of the second term, that is y z squared, correct? Plus dou by dou z of xz. Okay, what is this answer? Two y, okay, two y plus z squared, okay, plus x. So that is a divergence. Now I can directly apply. Therefore, this implies the flux required is equal to, I should solve triple integral. All the values are directly given. So x limits are there. X is equal to 0 to 2. Then y is equal to 0 to 1. Z is equal to 0 to 3. 2y plus z squared plus x dz dy dx. Okay, please solve this. So first we'll integrate with respect to z, right? Okay, that means this is equal to integral x is equal to 0, 1, y is equal to x equal to 0 to 2, y is 0 to 1. What happens when you integrate? This is 2 yz plus z cube by 3 plus xz from, I think, 0 to 3 dy dx. So that means this is equal to x 0 to 2, y 0 to 1. So this is, when 0, all the terms will cancel. So 3 into z, so 6y, correct? Then plus 9 plus dx, I suppose, dy dx. Sorry, what happened? Okay. Okay, okay. Fine, fine, fine. So now this is 0 to 1. So not 0 to 1, sorry, 0 to 2. When you integrate this, 6y squared by 2 plus 9y plus 3xy 0 to 1 dx. So this is simply 3y squared for the first term, right? So that is equal to 0 to 2, 3 into 1, that is 3 plus 9 into 1 plus dx dx. So ultimately 0 to 2, this is 12 plus 3x, isn't it? Dx. So this is 12 becomes 12x plus 3 times x squared by 2, 0 to 2. So this is 24 plus 3 into 4 by 2. 24 plus 6. expression. Find double integral over S, the vector f dot ds if vector f is equal to x into I cap, y into j cap, z into k cap over the sphere x squared plus y squared plus z squared equal to 60. So whenever this comes, I should understand that, okay, instead of finding this, I can apply Gauss divergence, right? So over S, the f dot ds has to be triple integral over a volume. This is del dot, correct, into dv. So this is the other possibility, right? Anyway, if the given f, this is the force, okay, assume that they can form it in this format. So if the force is given by this much, find the work. Find the work done, right? So once again, you will do the same thing. The question is still remains same. The work done, total work done is double integral over the S, the f dot ds, whatever they give, right? Convert this into triple and you solve. So you see now various forms of the question, right? Divergence itself is x plus y plus z. Let me just check. There is a derivative, correct? I think you have to check the equation once again. Kindly note what is the divergence means, correct? There is a dou by dou x, dou by dou y, and dou by dou z. So if you simply multiply I into I, j into j, and k into k, right? That's fine, but after that you need to differentiate. Perfect. So first you find what is divergence of f vector, which is del dot f. So first component has only x, so dou by dou x of x plus dou by dou y of y plus dou by dou z of z. Yes. How much? This is equal to, so 3. All right. So what they are asking now is I need to find out double integral over the surface f dot this ds has to be a triple integral over a volume, right? This is 3 dv. So since our intention here is to solve for the entire sphere, find out the complete range for r, right? Theta and phi. Okay, 0 to 2 pi and 0 to pi by 2 is uh, okay, 0 to pi. So you got it. Simply solve this. That is equal to 3 times integral. I'll write for phi. Phi is equal to 0 to pi. Then theta is equal to 0 to 2 pi. Then the radius is 0 to 4. Yes, what do you write here inside? Is it right? Okay, if I simply write dr, d theta, d phi, is it enough? Can you check? Yes, yes. There is a j coming into picture, Jacobian, and in a triple integral, what is the equal? Yeah, yeah, sure. Take your time, no problem. So you can see that the Jacobian is r square sine phi. So you have r square sine phi dr, d theta, d phi. Okay, yeah, please try to solve this. Anyway, the 3 which is outside will not get cancelled. Okay. Anyway, I have a only in this case I have a another method which is much more faster. So I have a 3 outside. What is this triple integral is actually solving? The triple integral, which is the volume of a sphere. So you know the equation for volume of a sphere, isn't it? What is that? What is that? 4 by 3 pi into radius cube. Radius is 4 cube. So 3 cancel. So 4 cube is 64 into 4. So 256 pi is the expected answer. Can you just check your answer? So we have not solved any question on verification of the Gauss divergence theorem. Now we'll solve. Okay, so this question is verify Gauss divergence theorem for this is the given f vector is equal to x square minus yz to I cap plus y square minus zx into g cap plus z square minus xy into k cap over uh, parallelism defined by 0 less than or equal to x less than or equal to 0 less than or equal to y less than or equal to b 0 less than or equal to z less than or equal to c. Okay, a, b, c are constants. So let's write the Gauss divergence theorem once. So that is triple integral over a volume, that is del dot f dv is equal to double integral over the surface vector f dot ds. 2y plus 2 times x plus y plus z. So that means I'll start with the LHS. The triple integral over volume, that is del dot f dv should be integral, I know that, x varying from 0 to a. So there is a 2 outside. Y is 0 to b. Z is equal to 0 to c. This is x plus y plus z dz dy dx. So when we solve this, we get this is a square bc plus ab square c plus ab c square. Is it? Okay, let's hold on to this. This is the left hand side. All right. So now what we are solving is new to us. We have not solved any question on this, right? Now actually you understand why in the previous problems, though the question was on double integral of s f dot ds, why didn't we solve that directly? Okay, you get the answer now to that. So let's go to the RHS part. That means I am supposed to solve, right, double integral over the surface. This is the given f dot ds, correct? I can rewrite this as double integral over the surface, the f dot some unit vector into ds. Is it okay? Okay, let's come back to this. Let's hold on to this. I'll draw something. Okay, let's say this is our x, y, z axis, and I want to draw a parallelepiped over here. So that means it should start with the two rectangles. Okay, one rectangle over here, one more rectangle. Okay. Okay, let's connect. This is going to be connected to this. These are going to. So most of the questions here will be the parallelepiped only, because that's the one which is easier. Okay, fine. Now you see how many surfaces you have, so many integrals will come, because it has to be double integral over surfaces, right? Means I have to do a double integral, right? Surface integral. Need to find out how many surfaces I have. Let me see. Let me check. So this is, let me say I have, okay, say this is the x-axis. Okay, I don't need that much bigger. I'll reduce this just to save some space. Okay, I don't need this axis at all. Okay, and I don't need this at all. Okay, now let's write. So that means this is the x-axis, y-axis, z-axis. Okay, so what is the equation of the front surface? Can you give me an equation? If at all I want to represent. It's parallel to YZ plane. Yeah, what's the equation? Y equal to 0 is this complete plane, because everywhere y is 0 because it is present on the xz plane. X equal to 0 is the backside plane, correct? Because it is present in the yz plane. So I'm asking the question, what is the equation of the front surface, which is, right, not x equal to 0, but x equal to something else. It's parallel to yz plane, and you move how much? What is the distance you move along the x-axis to reach that? So x equal to a is the equation of this plane. Now you see, you asked how do you justify that, right? So x equal to a is a plane, correct? Everywhere on this plane x equal to a, yz will change. So we cannot define what is yz, but x equal to fixed, right? What is the equation of the backside plane? As you know, it is x equal to 0. So now I change my question. What is the equation of the top surface? That is this one. What is the equation? Z is equal to c, correct? Similarly, what is the equation of the bottom surface? Z equal to 0. Perfect. Now, what's the equation of this right side? Y equal to b, right? So, how many total surfaces you have? Now you tell me. So, 6 surfaces. So, this S will be split into 6 parts. Okay. So, 6 surfaces you have to do 6 different surface integrals, add them together to get the answer. All right. Let's give the names so that we can trace which surfaces. Sorry. When x is equal to 0, right? So which is a surface that has a equation x equal to 0? The backside surface. So you know the limits of y and z, right? Because you don't need x to calculate the surface. Surface is present in yz axis. So y varies from 0 to something, z varies from 0 to something. Is it enough to calculate surface? Yes, that's all. So we know the double integration now, right? So just find out the appropriate limit, right, for that surface which you are calculating the area, right? All right. So let's give some names here so that we can track which surface we are talking about. So the central one I'll call O. Let me say the front surfaces are A, B. This is a C, D. So O, P, Q, and R. Let's say. Okay. Fine. So we'll start one by one. So this actually, I understand that there are 6 surfaces to be calculated. Okay. All right. So let me start with the first surface. Maybe I'll call that as a double integral over, say, okay, let me tell over here. So let me say S1. I'll tell you what is of my first surface. Okay, so maybe that is the bottom surface. Okay, so O, A, B, P. I start from here. So this is double integral over S1. I'm supposed to find out the vector F dot n vector into ds. Is it okay? Okay, now you tell me. What is the vector F? It's given, right? Vector F is given, but okay, but I need to find out what is the n cap. N cap is the one which moves out of this. In the sense, for a bottom surface, unit vector unit vector going downwards. That is the vector which we are talking about, not upwards, because I'm looking at a surface from bottom. I'm looking for, if you for a bottom surface, if you mark upwards, that's wrong because it is marking into the volume, which is inside your uh, part, right? So it's not that case. It has to be like this. So for a top surface, you can consider like this. For a right side surface, like this. Left side surface, like this, and so on. Okay. Now you tell me which unit vector is responsible for this operation. I is along x-axis. Which is the axis perpendicular to xy plane? Z. So I am looking at minus k. So what you do, you don't have to write the whole function, that f vector completely, you don't have to write. Just look at which is the term contains k. Okay. So in again, I missed one point. I'll write it here. In along OABP, what is the value? OABP is nothing but xy plane. In the xy plane, z is equal to 0, correct? So you see, right? You look at f, equation of f, in which you look at only k because I'm multiplying by k, right? So I'm multiplying by minus k, and also I'm going to put z equal to 0. So what happens over there? It is just minus xy into minus k into k, that is minus 1, right? So dx dy because the small change in x-axis is dx, small change in y-axis is dy. Dx dy gives you the total area. So I'm trying to find out what is the range. So x is equal to, x starts from 0, goes all the way till a, y varies from 0 to b. In that case, I should write dy dx, that's all. Okay. Dy dx. Okay. What is this answer? Calculate and let me know. So this is equal to a square b square 4. So let's move to the second surface, S2. I'm going to consider O, A, P, R. So along that, it's a left side surface. Okay. That is XZ plane, exactly lying on XZ plane. So that means Y becomes equal to 0 in that plane. And what is the N cap? Can you tell me for that particular? Yes, perfect. So that is negative G. So apply this to find out that. So I'll write double integral over S2, the vector f dot n cap ds is equal to, I have to write two variables. Anyway, I'll come back to that. Now, since I'm multiplying by minus j, I look at the f equation containing j part only, right? And I will put y equal to 0 over there. So when you put y equal to 0, I have a minus zx into minus j into j, that is minus 1, correct? So dz dx. So x is equal to 0 to a, z is equal to 0 to c. I think directly you can write. You don't have to solve because it's very similar to, yeah. So c square a square by 4, isn't it? Okay, let's proceed further. So I'll write the similarly S3. I'll take the backside circle so that it's going to remain same. OPQR. OPQR. So give me the equation for that. That is x equal to 0. And what is the n cap? This is equal to minus I. So I will write double integral over S3 vector f dot n cap ds is equal to h double integral, right? What is the equation? This is minus of yz into minus 1. This is dz dy. So y is equal to 0 to p, z is equal to 0 to c, right? You have b square c square divided by 4. Is it okay? Okay. Now, next I'm going to consider the top surface, that is drqc. This surface. Now you tell me what is the equation that you're going to consider for the top surface. Sure. Yeah, what's the equation? Yeah, sure. Take it. You want to diagram? Yes, sure. I'll show you. Yes. What is the equation of top surface? No, equation. Equation of the plane. Equation of the top plane. Z is equal to C. Perfect. Right? So that's the equation I'm going to write here. Along this, Z is equal to C. First thing. And I also want what is a unit vector? N cap. N cap equal to K. Right? Now you do this. Therefore, it is double integral over the S4 equals to F vector dot N cap ds. So equals to, I have to write two variables, right? So now we'll go back to, right, the equation of f containing k. What is that? Z square minus something, correct? Containing k, yeah, z square minus xy, but z is equal to c. So this becomes c square minus xy. Okay, into k. So k dot k cancels. Just write dx dy or dy dx. So specify x is 0 to a, specify what is y 0 to b. Okay, so this is equal to a b c square, right? Okay, minus b squared by 4. Right. All right. Yeah. So next one, let's go to the say the right surface, that is BCQP. Okay, that's 5. So okay. Now, okay, what is the equation here? What's the equation of this plane? So you can see that y becomes equal to b, right? So that means the n cap unit vector should be j cap. So that means the double integral over S5, the vector f dot n cap ds should be equal to, right? This is the right side plane. So I have to take y equal to b. So this becomes b square minus z into x dz dx. So this has to be now x is equal to 0 to a and z is equal to 0 to c. So this is equal to a b square c minus a square c square by 4, right? Okay. So which is the surface that is left over? Yeah, the front surface, right? Okay, we will do that. So this is the sixth surface that is equal to ABC. Okay, along this, what is the equation? Equation says that x equal to a. And what is the unit vector perpendicular to that? N cap equal to unit vector perpendicular to the front surface and coming out of that plane. Should be I cap, right? Okay. Double integral S6 vector f dot n cap ds is equal to, this is integral, integral. So I have to look at the term containing I cap in the f. So that gives me, there is a x square, so I am going to write a square minus yz into I dot I is 1 dz dy. So write the limits. Y starts from 0, goes till b. Z starts from 0, goes till c. Okay. So this is equal to a square bc minus b square c square by 4 is there, right? Okay. So that means the RHS should be equal to, add every term, right? You will get a square bc plus ab square c plus abc square, that is equal to the LHS which you had kept. Is it okay? So that's how we verify the Gauss divergence theorem.